things. So I will be recording. It picks up me primarily and things like that. So don't worry about seeing that. That's no big deal. I just need that for my virtual people. And you'll also see up here I'm sharing my screen. I do have a couple people joining us via Zoom and things like that. So they can't see you. You can wave at them if you'd like, but they're just seeing my screen. Yeah, you can tell them hi if you want. All right, so take a look at what's up on my screen. Just take a minute and look at it. Inside your own head, what do you notice? What do you wonder about? Just looking at that. Don't say anything out loud. I know you're like, oh, what is happening there? But that's what I want you to think about. Like, what do you notice? And what do you wonder about a little bit? Just take a minute and think about that. Looking at that beautiful pie graph up there. If I can, there we go. I can zoom in a little bit. There we go. Does that help? There we go. All right. Anybody want to share out? What do you notice? What do you wonder about? What do we think, Mason?
They're all the same percent, but the pie graph looks bigger in certain sections.
Okay, so Mason noticed that they're all the same percent, but not all the pie pieces are the same size, which if everything's the same percent, they should be, right? What else do you notice or wonder about? What do you think? Abby, what do you think? It's over 100%. That's kind of an issue, right? A little bit, okay. What else does anybody notice or kind of wonder about at all? What do we think? My question when I saw this was, who the heck did this? This made me a little nervous. I couldn't find like the actual school it came from, but this is from a high school. Somebody did this at a high school. So I found this because this unit, we are going to be graphically representing our data. So I want to kind of start with this. So when you make your own graphical representation, look at it and kind of think, hey, is there anything that really stands out that doesn't look quite right? Okay, so it kind of excites me you guys are picking out some of those key things from our pie graph. Yay! Today, our focus, we're not going to be creating any graphs today. Today, if my computer wants to cooperate, there we go. Today, we're going to be focusing on the actual organizing of our data. Okay, then the rest of this chapter, we focus on the actual graphical representation. Now, here's what I have done for this chapter. You basically get like a chapter on a page. Okay. Yes, it's a giant page. You can fold this however you want. The idea is, and again, you can fold it however you want, whatever makes most sense for you. Obviously, this giant sheet, I know, does not conveniently fit in a notebook. But in each of those blank squares, though, we will put each one of our graphical representations. So one of those boxes will go a pie graph, and one of those boxes will be a histogram, and things like that. Now, if you're thinking, Miss Kelly, that's just a giant piece of paper, I don't want to use it, hey, that's fine. This is an option for you if you prefer to just take notes in your notebook. I'm 100% cool with that. Okay. You're welcome.
Is this what you do every morning, Gail? Newspaper open. You read the newspaper every morning, Gail? I know you read the side of the newspaper.
How do you know what side the newspaper is?
Because I read it every morning.
The other piece of information coming around to you is information from our survey. I'm hoping you took the survey. I had 70-some people take it, so that's pretty good out of 90-some, and I have like 12 virtual people, so they may or may not have come on yesterday and taken it, so that's okay.
So
There we go. You're welcome.
I did
It's all right. There we go. Did you guys? I got you guys some. Okay. All right. So. All right. So the organizing piece. So I'm at the top left of your sheet. I'm at the top left of your sheet. Everything is filled in on my screen up here, but I left the definitions blank for you. So the first thing we need to talk about, just to make sure we're all on the same page when it comes to terminology, because these are things we will use throughout the unit. And some of these things will pop back up for us throughout the trimester as well, not just this unit. The first is that idea of raw data. Raw data is simply that. It's in its original form. So if you think of cooking food, if something is raw, it's how you got it off the tree, from the grocery store. It's not cooked. It's not done. There's been nothing done to it. It's in its original form. It's in its original form. So raw data, it's kind of like our raw food. It's in its original form. Your frequency distribution. We're going to be making a couple of those today. It's how we're going to organize our data. It's how we organize our raw data. It will be in a table. And we use what are called classes and frequencies. So if a frequency distribution uses classes and frequencies, we better talk about what those things actually are, right? All right, so a class, here comes some vocab from chapter 1. Some of you are like, woohoo, and others are like, yep, that test is done.
Yep.
Quantitative or qualitative category in which we place our raw data. So notice, though, it can be quantitative. Quantitative, we think of a quantity, which is numerical. A quantity is a number. So we might have classes that are numerical. Or they might be qualitative. Remember, qualitative is some type of quality, some type of characteristic, some type of quality. Or more so something that we're just going to call it by name. It's not going to be numerical. It's going to be something we call by name. The frequency, it's just how many of our data values actually fall into that specific class. So I know one of the survey questions was, of the 4 choices, what was your favorite school lunch? And I just picked a random 4. I know some of you are like, I bring my lunch every day. It was just if you had to pick one. Say forget your lunch, what are you going to pick out of those 4? And however many people chose chicken strips, that's going to be my frequency. That's going to be my frequency. So those top 4 are just some of the general terms that we need when we start organizing our data. We are going to create 2 frequency distributions today. The first one's going to be using our qualitative data. I'm going to start with the easiest one first. It's a categorical frequency distribution. So it's used for data we can place in specific categories. It's for that qualitative data. Or again, bringing in some of our ideas from our first chapter, we have nominal or ordinal data. So in other words, those qualitative things that really we're just saying by name. Name alone. They're not going to be numerical. We're not going to be measuring anything. It's just numerical. Okay? All right, so as you can see, again, we're still in that top left-hand box on your sheet. I already have the table piece set up for you. And the first column is labeled as class. First of all, which set of data are we going to do? How many minutes does it take you to get to school? Or are we going to do school lunches for this one? Which type are we going to do? If it's a categorical one, so we're talking qualitative data, we're going to do our lunches, right? So our 4 lunches were, let's see, what did we have? We had spaghetti. See if I can spell it right here. That looks pretty good. We had orange chicken, I believe I threw in there. Oops, and I can't spell orange. I got spaghetti right, but not orange. Here we go. Orange chicken, taco salad. And then chicken strips. Or nuggets. I put nuggets on there too. But we can just do chicken strips for ours, is fine. Now, the reason that second column is there, it's the tally column. Because this is the part where oftentimes when you guys have probably worked with data sets, things are probably already nice and organized for you. When you get raw data, it's not organized. It's just as you see it on the sheets I just handed out to you. So what our job is we have to go through each of those and tally it up. So take a look, you're in that far column. It says choose your favorite of the 4 school lunches. The first person responded spaghetti. So I'm just going to put a little tally in spaghetti. Then we have an orange chicken. Now I know some people, it's super tempting to go through and, I'm just going to go through and count the spaghettis first. When you do that, it's very easy to miscount. It's easy to double count something. It's very easy to skip over one. So I do this data value by value by value by value. So I did spaghetti. I did orange chicken. Now I'm going to do, the next one is taco salad. Then I have a chicken strips. Then I have a taco salad. And you can go ahead and work through yours, and then let's see if we match. And remember to do the 5. You just put the little slash.
Do it through the back of it too.
Mm-hmm. Yep, front and back.
They must be right next to me. What's the senior class next to me? What's the senior class next to me? Isn't that Mr. Horner? Yes. What's senior class? Yeah. The court.
Yeah, it can be that.
Well, I mean, like, not senior, I mean, like, what class? I don't know what he teaches them. Yeah.
Okay, help me out because I feel like I missed a chicken strip out there somewhere, I think. See if you guys, see if you match me.
Wait, orange chicken is 3? How'd you do that so fast?
What?
See if you match me.
Her? No, that's further than what
All right, so our grand total Our grand total should be 74. It's one of the nice things to check. I just knew I had 74 responses from the survey. I didn't go through and count. But you need to make sure, though, that however many data values you have matches your total frequency. That's one easy check. Because if you only have 73, it means you missed one somewhere. If you have 75, you double counted something somewhere. All right, the other piece of this, because not everybody took the survey like they were supposed to. All right, so if we look at our final column, I know some of you are jumping ahead looking at the travel time data. The final piece of this is, do we know how to find the percent? Now, we looked at that pie graph when we first started, and we knew, hey, our percent can only be 100. So, does anybody remember how we find the percent of our data set that's represented by spaghetti? Sarah?
Take the frequency divided by the total.
Okay, so frequency divided by total. And then what do we have to do with that? Multiply it by 100. And this pie works out pretty ugly. Let's go ahead, let's round to the nearest, let's go 1/10 of a percent. So let's see, we have 19 out of 74. And then 29 out of 74. Now, if we go through another check, oops, I forgot a decimal point there. Now, if we go through and add up those percents, as long as I don't miss a decimal point again here, we actually end up with 100.1. Why did we end up with 100.1? We were saying on that opening one, well, we can't go over 100. Why did we end up with 100.1? Because you're rounding. This is a great case in point of 100.1 is okay. Is 101 okay? No. We did too much rounding. So 100.1 is okay. Could I end up with like 99.9? Yeah, and that's going to be okay because we did some rounding on there. We did some rounding, so that'll be okay. So that brings us to the finish of our first categorical frequency distribution. That's our first one. The second one, if you go over to our second box, up at the top, we have grouped frequency distribution up at the top. This is going to be for our quantitative variables. And we're going to use this when the range of our data is large. If you have a large range, so having a large range means your highest and lowest values are pretty far spread out, we can group the data into classes. So it's not quite so daunting. We can. The steps in that box I already have filled in for you. Those steps are already there for you. And we'll just kind of talk about each one, and we will create our group frequency distribution. Give me a minute here to finish up that definition if you need to.
You're lucky I'm nice. What? Because I knew more than 1 unit. Because I knew you would hate it.
Now, here's the key.
You Emerson too.
Here's the key. If you're doing a group frequency distribution, your classes have to be more than just 1 unit wide. Your classes have to be more than just 1 unit wide. You want to use this, if your data values were just simply, let's say, 0 through 5, that's not a big deal. I can make a class for 0, 1, 2, 3, 4, 5. That's not going to be a very big distribution. That's okay. But as we look at our drive time data, how many minutes does it take you to get to school? Somebody actually put 0. I'm not sure if somebody lives like right next door to school or maybe right across the street. I don't know. I think it at least take you a minute, but somebody did put 0. So our smallest value is 0. Take a scan through. What's our longest time? I see a 45 minutes. I see a 45 on the back.
40-ish, but 45 the most.
And 45 is the most. So here's what you have to ask yourself. If you are the person needing to organize the data and you're trying to decide, do I just do some single numbers and just do more of that categorical one? Or do I need to go grouped? Here's what you have to ask yourself. Do I really want to write out a separate category for every single number 0 through 45? No, I don't want to. It's going to take me a lot of time just to write out 0 through 45 and then go back through and do all my tallying and things. So that's where the group frequency distribution comes in handy. So step 1, it says determine the classes. It says find the highest and lowest value. We already did that. The highest value was 45. The lowest value was 0. Then it says to find the range. The range is probably something you found once upon a time in like a middle school math class, I'm going to guess. Does anybody remember what the range is? How to find it? Abigail?
You add them all up and then divide by, isn't it the numbers then?
That's the mean.
Oh,
That's the mean or the average.
Take the highest number minus the lowest number.
Highest number minus the lowest number. So our range, we have 45 minus 0 is 45. Now I know 45 minus 0 is 45, but I'm writing it there though, so that when you refer back to this for your notes, you remember, oh yeah, that's how we found the range. Highest minus lowest. Now it says we're going to select the number of classes desired. Try to ensure the class width will be odd. And it says you're going to choose between 5 and 20. This is one of the parts I always get a lot of questions on. Miss Golly, how do we pick? You as the researcher would pick. When you're doing practice problems, when you take your test, I will let you know how many classes you need. Okay? I will let you know how many classes you need. So for today, let's do 7 classes. Let's do 7 classes. That's just what I have it set up for. Again, that is going to be up to you as the researcher. There's not a magic formula that says, here you go, here's your number of classes. Okay, it's entirely up to you. All right, so it says find the width by dividing the range by the number of classes and rounding up. Rounding up might be a new idea for some of you. It's not rounding off. You always round up to the next whole number. Always up. Even if it comes out to be 5.2, 5.1, you still round up to 6. It's rounding up, not rounding off. So we take our range of 45, divide by the number of classes. So we have 45 divided by 7. And it comes out to be 6.42. I can't have a class width that's a decimal. It's going to make setting up our classes really, really hard. I have to round up. Round up to 7. So that is our class width. That is our class width. Now, it just so happens our number of classes and the class width came out to be the same. Sheer coincidence does not happen often. Okay, then it says select a starting point, usually the lowest value, or it says any convenient number that's less than the lowest value. So if you're working with decimals, you don't want to start with 1.72. You'd want to start with 1. So choose something that's close to your lowest value. Our lowest value this time is awesome because it's 0. Select a starting point. And then it says we're going to add the width to get all the lower limits. Add the width to get all the lower limits. So we're actually going to fill in the left side first. We're going to fill the lower limit of every one first. We're going to add 7 going down the side. So plus 7, plus 7, going down the side. 7 is our class width. We're going to add 7 going down the side. Those are all of our lower limits. I can sneak a little plus 7 in there. Sorry guys, there's not a lot of space in there. Plus 7, because that is our class width. Now I usually get the question, or I know people out there are thinking it, but Miss Guy, why'd you add 7 going down? Why didn't you add 7 going across? Do not write this, I just want to show you. If I add 7 across, 0 plus 7 would be 7. My class width is supposed to be 7. But if I count 0, 1, 2, 3, 4, 5, 6, 7, how many values are there? There's 8. 0 through 7 is 8 values, so my class width is too big. So I have to add the 7 going down the side. If I add it across, my width is too big. So what will be my upper limit, do you think? 0 through what? 6. Now the adding 7 thing, it works the same on the uppers. You can just keep adding 7 going down. You can just keep adding 7 going down. For your class boundaries we're familiar with from last chapter. We're going to, in this case, since we have whole numbers, we're going to subtract a half off the lower and add a half to the upper. And when we do this, guys, this is why you want to choose numbers that are convenient. As long as you always choose whole numbers for your class limits, which you should, even if your values are decimals, make your class limits whole numbers. Make your class limits whole numbers. Subtract a half off the lower, add a half to the upper. So then, do the same thing all the way down. Finding those class boundaries, if you do have values that are decimals, it helps us close up the gaps. There's a lot of values between 6 and 7 that aren't accounted for right now until we do those boundaries. There's a lot of values between 13 and 14. If I have a value that's 13.2, if I don't have class boundaries, I don't know where to put it. So keep rolling with that. Now it's going to be your job to dig through the traveling to school data. If you want to work with the people around you, that's fine. If you want to maybe read it to the person next to you and they can decide where it goes, you sure can. A couple of these though, where were they? A couple of them on the back. One person said, when I'm at my dad's, it takes me about 10 minutes. When I'm at my mom's, it takes me about 4. let's go with the first one. Let's just do 10 minutes. So I'm on the back, and it's the one that has like the sentence to it. And see, here's where I learned as a researcher. I thought I was doing pretty good by saying round to the nearest whole minute, but I didn't think of a situation like this. Somebody might have 2 different travel times. So now as a researcher, I know I'd have to clean up that question. Go with 10 minutes for that person. And there's one down towards the bottom that says 5-8. Let's just make it, let's just make it a 5. Make it a 5. There's a 5-8. Just make it a 5. So go ahead, take a few minutes, sort through that data. So double check yours with mine. And sorry guys, when I set this up, I printed this off before you guys did your data. I was trying to get ahead of the game. I didn't realize we'd have so many people in that 7 to 13 minute space. A lot of you must live pretty close to school. So double check mine. If you notice at the bottom, I have that it totals 74. It's how many data values I have. Now that doesn't mean just because I get 74, it doesn't mean that I didn't misplace a value somewhere. I could have easily misplaced something, but chances are if they add up, at least you have all your data values accounted for. I could have accidentally put a 5 in the wrong spot. Maybe accidentally put it in the 7 to 13. But make sure that you have the right total. Otherwise, you might have double counted or you might have left something out. So that's one of the nice checks you can do. Okay. The final thing that we need to do is take a look at what's called a cumulative frequency distribution. Okay. With a cumulative frequency distribution, what does cumulative mean? Everything just keeps adding up, right? Everything keeps building. It does. So what we're going to do, we are going to have in that left column, we're going to use our our upper boundaries. Our first lower one, so we're going to go less than negative 0.5. And we don't have any values that fall there. That first row, if I asked people, like I said, I've taught this a lot of years, that first entry is the one that is most often missed. We always want to start with 0. 0 of our data values fall below our lowest boundary. Then from there, now we go less than. If you just want to use little quotes, you can. Now we do less than 6.5. So I go from my very lowest boundary, where I know nothing's going to fall below that. And then from there, I use all of my uppers. From there, I use all of my upper boundaries. So we have less than, you can just use little quotes, is fine. So less than 6.5, there were 15. Less than 13.5. Now we have to add together though, because it's not just the 29 from that row, it's 29 plus the 14. Or excuse me, the 15. So we've got 44. Less than 20.5. Now we add on another 19. So we're looking at 63. Less than 27.5. We add on another 6. Less than 34.5. We add on another 2. Less than 41.5, we add on 1. And then finally, when you get to that last boundary, you should have all your data values accounted for. So notice that cumulative piece means it just keeps building. And when you label, I'm fine if you put the little quotations there instead of writing out all the less thans, that's fine. It shows me you have the idea. Okay. Oh, I already filled it in on yours? Oh, that was nice of me. But yeah, don't worry. If you have to write it out, that you can use the quotations is fine. But keep in mind, if you look at your group frequency distribution on the left and the cumulative on the right, there's one more row. So we do need that 0 row. We always want to start with 0. Okay. I will go ahead and put up the assignment piece. Make sure, I covered the gist of 2-1. Make sure you read it, but also know that you will have most of class Monday to work on this. You'll have probably at least, I would say, a good 40 minutes of the time on Monday to work on this. So if you want to get a start now, you sure can. That's kind of up to you. If you're like, nope, I did a lot of work in that lesson, you want to take a little break today, that's fine. You'll have a pretty good chunk of time on Monday.